Hi again. We continue our topic of offensive security, and I ask you for a very warm welcome to Daniel with his speech, New Malware Developed to Target Industrial Control Systems. A very warm welcome.
I love the introductory music. First of all, everyone, thanks for being here. Thanks for joining us. I hope in the end you get something interesting out of this talk on a very specific type of malware for control systems. But first, a very quick introduction. I'm Daniel Kapellmann. I'm actually Mexican, but I've lived in the US. Right now, I live in Amsterdam, coming from there to the conference. I work for the group of cyber threat intelligence, and I am one of the leads for the team for industrial control systems, particularly, and recently also information operations. I guess that's as much. If you want to know more, I share a personal website. But let's go immediately to the topic for today. So, first of all, I wanted to bring up a bit of the relevance of what we're going to be discussing about for those that are not as familiar with the concept of industrial control systems. So basically, when we discuss about this topic, what I refer to is particularly the combination or the intersection between engineering and computing, and that's basically what helps us to make automated processes, for example, for energy, water, manufacturing, pharmaceutical, whatnot. So in this case, what you're going to be hearing today is a very unique situation, because malware that is developed for targeting these type of control systems is very rare. It has been seen only a couple times in history, and the reason is, well, there are multiple reasons. One of them is that it's fairly complicated, so you need a big teams to go and develop. Second thing is that historically, you would have to know specifically what type of device you want to go and target, so most often this malware was used once and then never again, so it's a big investment, few return. It has absolutely no financial gain, at least until now. And, well, so there are a few actors that have actually engaged in this. And so, we have seen it, when I say that it's really rare, it's because you can count it with your fingers, literally. This is the timeline that we use normally to describe the evolution of OT security. And actually, I include there a couple points that are not specific malware, but the cases where we have seen ICS malware as something existent are, first of all, Stuxnet, 2010. It has been heavily documented. It refers to a case against Iranian nuclear centrifuges in which basically this malware was deployed to delay the program and basically mess up with the centrifuges. Many years later, 2015, 2016, we saw two different attacks. They have been, let's say, attributed to Russian-sponsored actors, in which there were power outages in Ukraine caused by using this type of malware. Particularly the second one, which name is InDestroyer. I ask you to please remember that name, because it comes later back in this year. 2017, we had Triton. That was, until then, like probably one of the most innovative cases, because finally we saw this specific malware developed for something that's called safety instrumented systems. It was the last layer of security before blowing up or being able to blow up a specific energy facility. And, well, that's something we responded to. We analyzed. It was fairly specific, the malware. There was a huge attack, you know, jumping from the different layers of security and the different layers of the organization. But then, still, it was something fairly specific against one target. And then we come to 2022. And just in the beginning of the year, we were working like crazy because we had these two new cases. We had INCONTROLLER, which is the one you're going to hear about today, and you had InDestroyer version 2. InDestroyer version 2 was one module from the 2016 malware. They put it back and they personalized it. And I'm going to briefly discuss a bit of that, but right now our focus is on INCONTROLLER. So what is INCONTROLLER? First of all, as I mentioned, 2022, February, beginning of the year, in the context of conflicts, we don't know if related, but you know, around those times when it was starting, we find this, well, basically we get access to this specific code from INCONTROLLER, and then we start working with different organizations to analyze it. Particularly, we call out here Schneider Electric, because that was one of the specific type of devices that was impacted. Just to highlight, normally if you want to go after control systems, it's not one single malware for everyone. It is a specific, you have to go after a specific device, after specific technologies, specific protocols. So in this case, reaching out to the vendors was very important, and the most responsive and direct collaboration was with Schneider. And there are a couple of additional publications there that we refer in case you're curious in the future. But so what is actually INCONTROLLER? By INCONTROLLER, we refer to a set of tools. There were actually 5 different tools. It's actually a bunch of code. It took a lot of people and a lot of time to go and analyze and figure out how it worked and whatnot. And right now we focus on 3 of those tools. 3 of those tools are the ones that go after control systems, specifically industrial type of applications and devices. And there were other 2 modules that were specifically, it was basically how to exploit a vulnerability in some specific motherboards, and it was a backdoor, basically for Windows components, and So those 2 components, we do mention them briefly, but it's not the focus of our analysis. We focus mainly on tag run, code call, and shell, which are the 3 control system modules, which, on a nutshell, tag run refers to most likely a reconnaissance type of module, where the actor takes advantage of a protocol that's called OPC UA, which is basically used for transferring the different languages that you speak at the factory or at the production level to turn them into machine-readable language. So basically, so that you can push it to your Windows, to your Linux, to basically your machines, and you can see the data and understand the process. Then we have the 2 others that are code call and shell. They are actually specific modules for a specific type of devices, a bit broader because they go after certain protocols. The first one, Schneider Electric related. The second one, Omron. Omron is arguably a smaller organization. It is Japanese, also sells different types of controllers. And well, I'm going to go much more in depth into each of these modules, but this is just an overview, which then we decided to depict with the structure. Now, this structure does not mean that we saw an attack happening like this. Actually, no attack has been seen. Right now, it is the analysis of the code of the tools that exists. So, given that we had the different tools, we tried to conceptually analyze why or how would an attacker develop such tools, because it's fairly specific. And then there are 2 theories, 2 possibilities. One of them, they are starting to develop tools for different types of devices that they can go and drop against a larger number of victims. The second one is that they had already a very specific victim in mind, which is most likely how ICS attacks have happened historically, and then they were planning to use it at different stages of the attack. What you see here is actually something that we call the PROIDEA model. It's something very common for control systems, which depicts the full structure of an organization that does any physical production, and it shows on the higher levels, it's the enterprise. It's basically what we're most familiar with. Normally, it's the computers, it's your email, you send data, whatnot. Then oftentimes there's a combination between those higher levels where you also see some of the data about processes. You might see, like large level enterprise systems. And then there is normally a separation, basically like some sort of, they call it air gap, but it's not as perfect as it sounds. So basically this demilitarized zone where you separate the IT from the OT, or the control systems. And then levels 2, 1, and 0 get every time more, let's say, less clever. You don't have the computers in there. What you have on level 2, for example, is some computers. You have some what we call PLC, Programmable Logical Controller, which are the ones that facilitate how the process is going to work. And then on the lower levels are the least clever, which is basically sensors, actuators. It's a motor. It's going to gather data. It's going to basically it's very limited on the functionality. So what we see is that, as you find here, we have 3 modules. One module seems to go at the higher level, more on the process data, and 2 others seem to go directly at the production level. Separating this into pieces, then the first one, which is staggered, the OPC UA. As you can tell, we were assuming here you might see, normally you see this type of servers where you push data out from the industrial process, specifically to understand what's going on with the process, what you're producing, how much you should produce, and whatnot. And then we were considering that most likely the other 2 tools that we identify would be used with the framework of this attack, getting access to computers, moving around, lateral movement, whatnot, and then eventually being able to drop this tag run module. Tag-run module gathers information, and as you will see in a couple seconds when we describe the tag-run module, it has some capabilities to let the attacker know how to communicate afterwards with these controllers. So by the information that you gather in there, you can then basically identify where you have the specific PLCs and models that you're going to be targeting. But now, actually, I don't know why we did this, but all of them directly. So this is a very quick summary of a highlight before getting in depth into the tools. What we saw in here was basically fairly complex amount of software. It wasn't a single small piece of malware, but it was actually many different modules, and all of them contain a much larger amount of code, but it was very clean and very beautiful. So it was depicting a large, at least a very specialized team working on this type of malware. The second thing is basically that we don't know if the tooling is going to be used together or separate, but in the model you saw, it was like our depiction of how it would be logically used together. However, it does not mean that the actor is not still going to build more modules, so it could still have higher impacts than what you see in this diagram. The fact that the code is extensible, again, just that you can add more modules, and we're going to discuss more of that more later. Then about the targeted devices. One big question in the case of industrial is like, why would they decide this is Schneider? Why would they decide this? Why wouldn't they go after Siemens, Phoenix, like different type of devices? And up until now, our response is most likely there might be some specific victim. It is difficult to tell. But what's interesting is that the devices that they chose are specifically used in a large variety of industries and in a large amount of machinery that most often it's included in the machinery without your knowledge. Because they have the different parts, it can have different pieces of firmware, it can have different pieces of hardware, like in these cases. And so it is difficult to tell right now where this malware is going to actually be deployed or where it was planned to be deployed. Most likely we're still going to see it, so it's going to be something interesting for the future. And then very likely we consider state-sponsored based on the multiple factors, but also basically the complexity of the tool and the history for control systems that is basically as having no financial benefit. And yeah, well, finally, the capabilities that it has that are more for disruption, for sabotage, basically for something physical rather than, again, acquiring financials. That is the full idea. Now, you all know what's INCONTROLLER. If someone asks, you can tell like very quickly, something simple. But it's actually, we can get more in depth, right? So, the module by module. The first module that we have was the tag run, specifically. Tag run, as I was mentioning, refers to the piece of the malware that interacts with OPC UA, with this specific protocol to transfer to machine-readable language. The capabilities that it had was basically, well, first of all, yeah, you can just go and ping and search for devices. You can read and modify the OPC tags or values. What I mean by a tag is basically every tag is a value that you're acquiring, for example, from a sensor or from a motor, that it's telling you what's going on in the process. So basically, it can tell you what the process data is. And there's something very interesting here. When I say it can read and write, the big question is, why would you want to actually write a process value? Well, if we go back to 2010 to the Stuxnet attack, the old Iranian nuclear centrifuges, one of the things that the attacker was doing was that you don't only attack, like the device, but actually you also have to deceive the operator. So by modifying the values, you can either generate an impact on the process or deceive the operator so that they think that the process continues operating in the same way while it's actually doing something that it's not intended to, or it might be even in danger of being impacted directly. And then, of course, it had a couple of login methods. It tries to log into the specific OPC UA, the servers, where all this data is collected, which, yeah, I mean, it was trying to use basically some default credentials. It can do it by certificates, brute force it at some dictionaries, and yeah. So, specifically, that was for tag run. That was basically for the reconnaissance. But the two most interesting for us are code call and shell. So code call, which is the first one that was specifically for Schneider Electric, had mentions of a specific module, TM251, a specific type of PLC. Again, we don't know why. It is fairly specific, and it is very tricky to know. But what was interesting is that beyond the specific attack on this device, it was using protocols that are fairly used by other industrial applications. So the first one was well, they were using some Modbus for some of the reconnaissance, but they are also using something that's called in here EcoStructure, Machine Expert, Submachine. It receives many names. It's basically a Schneider Electric proprietary type of protocol that is then based on a different protocol, or not protocol, but a framework that's called CodeSys. And CodeSys very often supports the creation of many different proprietary and non-proprietary industrial protocols. So you might have CodeSys running in a ton of devices, in a ton of protocols, and without your knowledge. So basically, what they built, besides from being good for this specific device, it is fairly scalable, which is very interesting for control systems. And then basically, the attacker can try to log in. Once they log in, it has a capability to mimic the workstation. Also, just a fun fact, for the PLC to work, you need a computer. A computer normally makes sense to call it workstation, but if you are in ICS, they call it engineering workstations, because it has to be, it has to have its own name. Sometimes they're special, but most often it's a computer, right? And then, then you can drop a series of commands to disrupt the actual, let's say, the actual functioning of the device. And you can crash it, you can add, modify, delete different capabilities. Then about the devices specifically, we mentioned the TM251, which was one module that exists, but we also found mentions in the code to the TM222. And this TM258 is very interesting because right now it doesn't say much in the hardware. Well, believe it, it didn't say anything for us either. When you see the device, there are so many, it's so unique that you reach out to the vendor, you start learning about it, and the vendor was telling us that this TM258 was the predecessor of the TM251, and the only mention that we got was that it tries to use default credentials from that old version. So it's actually difficult to tell if the actor was developing this in a test environment, if they were familiar with the device already, if maybe they already know the victim and they already know that it's going to work. That's one of the things that make it super interesting. And then the last thing is, like we mentioned, that there's no evidence that they were trying to target other devices, but based on how it's developed and the specific protocols that they're using, the capability to expand to other type of devices definitely exists. Now, OMSHell. The second protocol that we got into is, the third module that we got into is specific for this type of OMRAM product. It actually uses two protocols to work. The first one is FINS. FINS is a proprietary protocol from OMRAM specifically. And the second one is HTTP, which for us it's also very unique. Normally industrial devices do not use HTTP, or they use it, but there are some that might be internet connected, but it's different. Normally you don't try to leave everything internal from your plant as with this capability. So in this case, the interesting thing, the most interesting thing from this module is that, first of all, what it does is not only get access to the device, but actually what it focuses on is turning on telnet. And once it turns on telnet communication, then it starts dropping all the connections. The other thing that's interesting here is the capability to read and write EtherCAT. EtherCAT is yet another protocol, in case you were wondering if we had more of those. EtherCAT is mostly used for sensors, for actuators, basically for the very specific devices that do the actual physical, let's say, actions. And well, so it has actually this capability, and no wonder it also has a specific module for something that's a servo. Servo is basically a motor that is more precise. So it is fairly logical when I think of motor, just something, maybe turning around. A servo is a specific type of motor that's going to be turning, but a specific speed in a specific, let's say, frequency that I need. And then these are the three devices that we found. So specifically, it was referring to the two that you see on the left. Well, actually, I'm having on the other side, sorry. Anyway, the two, NX and NJ. And then the servo that was, it's very unique. It's very difficult to tell why they chose this specific servo, because most likely in different places they're going to be using many different ones. And as you can tell, it's even very cryptic, because like the name of the servo is R88D1SN10F. Most of the devices you see at this level are fairly specific like this one. That being said, what's very interesting in the pattern that we found with these two devices is the following. is that these two devices were one of the few that Omron specifically documents to be working with HTTP. So that is the reason why we also consider that it might be possible that this module may be used with other PLCs from Omron firm, based on the fact that they support this protocol for communication. And even though this is the primary method for communication with the devices, the actor also used the FINS protocol that we mentioned was proprietary. The interesting thing is that the use of FINS protocol is limited only to identifying devices. So it goes and tries to find any OMRUNs that it can, and once it finds the OMRUNs, it was running this condition where if it found an NJ or NX and whatnot, then it's going to run, and then it's going to start turning on telnet, and then it's going to start trying to communicate. It's basically like a full process that they have in here. And all of this is basically actor operated. So basically, it's not something automated. Is most of these processes, which is something I'm going to highlight in a couple minutes, is very unique because normally for industrial type of attacks, you don't want to be poking there into the target network because it's most likely they're going to be able to find you if you mess up with some of the process. And finally, the potential, we say potentially supporting tooling just because they were kind of like packed together, but that we can't tell, is first of all this exploit against, it basically works with some motherboards that are used on what we call human-machine interfaces, HMIs, which is basically the way in which an engineer visualizes a process. And then also for some engineering workstations, some specific types of computers that are often used in industrial environments. And then the second thing is iScore, which is a backdoor. Of course, with all the capabilities you would expect for such type of backdoor, that it has command and control, it can go modify files, upload, execute commands, and whatnot. So most likely, this might be the type of tooling you would use through the initial stages of the attack before getting to the controllers. Once you get to the controllers, you have to get fairly specific, and that is why those three modules become fairly unique in its type. And so attack scenarios, when we think about like how it's actually going to look like, we came up with 3 possible scenarios based on the type of capabilities that we saw. The first one was you can basically disrupt the controllers and shut down operations. So basically, if you go and search for the specific controllers from Schneider and the specific OMRUN, if you go, for example, and run some of the modules that were specifically for wiping the memory, for basically stopping the process, for basically, any of they had also a denial of service somewhere around. If you run any of these ones and then you stop the controllers, you might think that probably you're going to have an impact on stopping or delaying the production. The second one is sabotage. Given that they have this capability in the tag run module for modifying the tags, it is possible that what they might try to do is modify production. For example, if you have a factory and in your factory you produce airplanes, and then you modify some of the values of the production from the airplanes, then you're going to have a big set of faulty airplanes. That is the type of sabotage you can do. And it has been theorized. That's fairly specific. It's more like a supply chain type of attack, but it could happen. And then the third one, which is like let's say the worst case scenario that we always work with in OT, in control systems, is physical destruction, right? Which is the capability of, by modifying how the controllers work, by knowing all about the process, because you have these modules to look at the process, you turn it into a situation where it's in an unsafe state, and then something might happen. Like in the 2017 attack in the Triton that we saw, where it was very clear that there was an intentionality for destruction. And then, well, this is just like to put it all in the framework. Then Tagron, which is the module for reconnaissance, we would expect that it would be used for enumerating the actual devices, for finding the IPs, where they're located, finding the specific data, learning about the process, and then you can jump into each of the 3 scenarios by using code call and OMSHell. In terms of attribution, I am not going to do official attribution. I just highlight that. I was actually having that discussion with someone yesterday. Attribution oftentimes is fairly complex. And with this type of malware where there's so much obscurity still towards the actor, it would be, it wouldn't be specific enough. But what we can say is, just from the analysis of what we've seen so far, it does not overlap with any groups, but we do believe that it might be, it is possible that it is related to Russian-sponsored actors. the reasons why initially we consider that it's a state actor is, first of all, the complexity of the tools. As I mentioned, this is something that you don't like sit down in your computer and write over 3 years, but rather it's a team of workers that actually understand the different processes, the different controllers. Building something for these controllers actually needs you most likely to have a test environment, or at least to know something about where it's going to be used, why you're going to build it. It is basically much more in depth. The second thing, expertise, which is similarly, and the third one is the lack of financial resources. So yeah, the fact that no one's going to make money out of this makes us believe that it's definitely not like an organized cybercrime type of group, and well, it would be very unlikely it would be an individual, separated individual. I wouldn't say impossible, but well, most likely impossible. So. And then we have limited circumstantial evidence to mention this Russian nexus. Unfortunately, for the sensitivity of the topic, we cannot discuss some of the things that we've observed. But what we can definitely do so that it stays on you, and it's not like, since we don't have an official attribution, is just to highlight this timeline of threat activity that we have seen mainly for control systems. Specifically in control systems, all of the attacks actually, or at least actually probably all, that have been documented, most of them that have been documented were tracked eventually to Russian-sponsored activity. So what you see in here actually is the first 2 cases were more on reconnaissance level. 2017, there's another big reconnaissance campaign, both of them attributed to known groups. 2015, 2016 are the 2 Ukrainian power outages. And those, it wasn't anything that secret for the attribution. It was almost like the actor wanted to signal it. There are full talks where we discuss why it was signaled and whatnot. There's more like geopolitical context into why it is so simple to do that attribution. Then Triton, we actually worked on that attribution. We have a fairly solid reason to how we got from one point to the other. There's also a blog on all of these ones, so if you're interested, let me know. And I'm super glad to share for the details. Unfortunately, I can't share right now everything. And then, well, lastly, in 2022, we don't know, but InDestroyer v2 is using a module from a prior attack that was already attributed to this group. It's called Sandworm. So it is most likely that the group might have reused it, given there's a conflict. It happens in Ukraine. It happens during these times. And it's using a module from a previous tool that was already used by this actor. However, again, there's no formal attribution yet. So this is just like a high level, and hopefully we will get more information in the future. Now, that being said, I don't like to just come on and drop a ton of malware and say, like, look, this is very interesting, enjoy it. But actually, I like to give a view of the big picture of what does it actually mean, this specific malware from 2022. And basically, it highlights 3 specific capabilities in, sorry, I say here OT. OT is the same as ICS, control systems, operational technologies. The latest in OT malware, and what we saw in INCONTROLLER and in InDestroyer version 2, the 2 pieces of malware we saw this year, is we identified 3 characteristics that makes them unique. The first one is that both are reusable. Both can be used to target multiple victims, differently from other ICS attacks that we saw before that were developed for one specific victim. It would be very difficult to go and reproduce, but now we're seeing that actually there is an intentionality to use against multiple targets. The second one is we say it's extensible. So yeah, you can build upon the code of this malware fairly easily so that you can go and add additional capabilities, additional modules, additional devices, whatever you need. And finally, operated. Basically, different from, if we go back to 2010 when almost the discipline begins with Stuxnet, it was a malware with worm-like capabilities. It basically goes from one computer, search for a specific type of Siemens device, it goes to another Windows computer, searches again for the Siemens device, and eventually deploys the payload. In these cases, we're seeing tooling capabilities that the actor can go and modify as they go and do the attack. So actually, it also highlights a lot of capabilities to go and actually get access to control systems networks, which is most often a challenge. Once you're inside, security is much lower, but being outside, it's difficult to actually get in. And so, to illustrate a bit of these 3, this is actually, well, the first one, the case of INCONTROLLER is the one I just discussed. InDestroyer version 2, the other big attack that we saw in 2022. The only interesting thing to highlight here for the reusability is that small line that you see below. That it's basically when you try to drop, when the actor was trying to drop the malware, they dropped this specific list of commands where they added some specific paths, they added a specific IP, they added some specific assets, and basically customized it to attack the specific victim. And we have different samples, so we have a blog showing how the actor was customizing the samples for different energy facilities. Because they tried in a couple, it didn't succeed gladly. But then about the extensibility of the code, yeah, the fact that you can go and add additional capabilities so that you can scope it. And here we actually pair it up with something very interesting, which is, if you remember a couple seconds ago, one of the timelines highlights like 4 or 5 specific espionage campaigns. So if you have this type of extensible code, you can go and tailor it to the specific target that you want, to the specific, whenever you have knowledge about that environment. And this is something that is not new. We have seen this type of campaigns specifically for information about control systems for several years. The first one you see in there is actually, it was China-sponsored 2013. It was mainly getting information from people in OT security field and OT security operators. He was trying to gather specific data about, technical type of documentation. 2017, that was another one that was super famous. That was a Russian-sponsored actor. It's called Temp Isotope, but other companies call it Dragonfly. And also it was gathering this type of information. The image that you see here is actually, we rebuilt one of the images that they were actually collecting from the machine interfaces. And the third one is a much more recent from APT 29 that happened in 2020. And basically, Mandiant was what was the big company to shout and say like, hey, thousands of companies are being right now basically compromised, and they are looking for a lot of types of information. And of course, it's not only espionage. You can think that it's complicated to get this data. Normally it used to be, but now you can also find it in some other types of attacks. So this is actually the full asset inventory that contains the specific assets, the specific IPs, specific ways to communicate from which computer, etc. All the information from a specific network, and also some images from the processes from a Latin American oil and gas company. We also have a blog on this. And this one actually was exposed in a ransomware leak. So if you actually go and look into ransomware leaks data, you can find wonders. And finally, the third one was operator. Like as I mentioned, you first have something like Stuxnet, then it evolves as it increases in capabilities, and eventually we see that the tools are operated directly by the operator. And one thing that we normally like to do is to compare this with the growth, for example, in ransomware, where initially you saw the same. It was kind of like worm-like capabilities. Let's see how many computers I can go and infect. And recently, we have seen the numbers increase significantly in the number of cases as the operators get more involvement, and you see this community, like actually engaging in the attack, what we call a post-compromise attack. So we see there is some certain parallel in here that might speak about the good capabilities that an attacker gets from this type of operated malware. And so the last section that I have here is specifically on some recommendations. I'm going to browse a bit through those because they are actually more like built specifically for if someone works in this type of organization, has this type of ICS visibility. But otherwise, it's still, I think, interesting to know. So on the high level, the first thing that we're highlighting is that as a defender, given the few data specifically that it is about signatures, about specific details. Second thing, the fact that the signatures are not going to help because the actor hasn't deployed it, so they're going to deploy it very differently, most likely, and they keep on having the capability to improve this tool. So we recommend mainly to figuring out if you have these assets, which is not as simple because, as I mentioned, oftentimes the different assets that I mentioned, different devices, are embedded in bigger machinery. So it is a bit tricky, but we do recommend taking a look and trying to find it. The second thing is, of course, there are like a lot of general mitigations that we have from specific vendors, from governments and whatnot that have been pushed through the year. And well, it might sound fairly logical when we mention here, like take a look at logs, take a look at behaviors, take a look at like nothing that goes out of your norms. But it is not as simple when you consider it from a control systems perspective, because oftentimes operators have few visibility into this type of traffic, so you really need to dedicate a lot of work into, okay, I'm going to look at these couple assets. But this, if you want to get more in depth, there are all those recommendations if it affects your organization, or we can definitely talk more about it. what I thought would be more interesting for right now, specifically for this conference, since I know that there's a lot of people with very cool expertise, would be more to discuss about the discovery methods, for which I provide 3. Well, 2 specifically. The first one is if you actually have visibility into a network where you have this type of traffic, specifically from the protocols that have been mentioned through the presentation, well, you can specifically look for the behaviors that we mentioned in Tagron and CodeCall. And there is actually a very good talk about, there's a guy from, I think the company was called Insane Forensics, that is discussing how they took these blogs and he was trying to look for these specific behaviors by analyzing network traffic from these assets. And he actually gives some recommendations, very interesting as well, highly recommended, it's on YouTube. And yeah, so basically we would look in the case of Tagron and CodeCall for the specific type of behaviors of credential brute forcing, anything that goes out of the norms of what your controllers normally do, which oftentimes you do know what your controllers do. They actually have they can do, for example, a ping in the case of Tagron, so that's something that unless you're aware of, you might want to look into. But the most interesting one is actually Umshell, which doesn't mean it's the most likely to find, but it is very interesting. Because since you have here the FINS traffic, which is fairly unique, fairly proprietary, and it's going to be basically scanning for FINS devices, that is something that's going to make a lot of noise. The fact that it's HTTP, because oftentimes you don't necessarily need to have HTTP within your actual industrial network, so it's going to be something unique. And the activation of telnet daemon. So also, if you look something about specific telnet and your FINS devices and you're not aware of using it, that might be a very clear type of indication. And the final, which is a bonus, this one actually is more about something that we do in our team. I mean, like, since we do threat hunting, but we want to go and look into different repositories, I know that many of us might not have a direct visibility into industrial control systems, but for sure you have visibility into different type of malware repositories. So let's say, I don't know, well, I'm not going to call specific names, but let's say different repositories, different sandboxes, maybe you have your own. And then basically, we have looked in the past for this type of malware. And the things that we mostly focus on are basically using strings from industrial protocols, from the specific vendor products. So here you saw a lot of specific products, a lot of specific protocols. And if you get the chance to go and play, test with some of these devices, you can also go and try to identify, for example, by analyzing basically how it works or any unique type of strings that you identify. So actually, these are the 2 cases you see here are 2 random cases where we looked for malware with OT capabilities, let's say. And actually, the second one, IronGate, is very, very fun because it's something, no one knows until now. It was just a PhD or something, but we identify it by looking VirusTotal specifically for these type of strings. And right now in the story version 2, we would have found it as well in the same way. So if you want to go and hunt for that, that might be something interesting. If you're interested in the future in getting more into ICS, we would love to get some more company. And yeah, I think that's all on my side. I hope you find this useful, and thanks for everything.